Hey folks, so this request came in just recently, and it did make me think, yes, I should have done this one already. So yeah, carbon capture, such a big deal at the moment. So I'm going to try and give you a rough guide to what it is, how it works, and just some of the pros and cons. A bit more drawing in this one and a bit less writing. Well, a bit of writing, but hopefully not too much for you. So basically, if you start by just sketching some land like this. Okay, and then we'll pop some waves in there. So this is representing the sea. There we go. And then, so what we're going to think about is really what's happening with carbon dioxide. Okay, so if we pop that up there, carbon dioxide, that's what we breathe out, or CO2 as it's commonly known. And it's what also comes from using fossil fuels, farming, transport, so lots of an industry, lots of different uses. Okay, so it's in the air, it's in our atmosphere, and we know that it's contributing to climate change. So where does it go if it's not just going up and out into space? Well, CO2, if we put it in a little box like this, actually some of it goes into the ocean. So this is called ocean absorption. So if we can write that in there, ocean absorb, that's got a P, T-I-O-N, ocean absorption. So the ocean does quite a lot for us actually, absorbing CO2. The other place it goes is the soil, and that's that same word again, absorption. There we go. So we draw an arrow going to the soil. If we pop in a couple of trees, obviously they wouldn't be quite this close to the sea, but yeah, if we put some trees in there. The other thing is it goes into biomass, so we call that biomass absorption. Okay, so that's really cool. So what's happening here is the CO2 is being naturally stored in the trees, stored in the soil, stored in the ocean, and that's okay, but the problem is we're producing too much of it. We're producing it from things like industry. So if we draw over here, let's have our big tower and our factory. This is obviously, a sort of pretend situation, but it's true in many places, especially newly emerging economies. So this is from industry, okay, industry CO2. Now, what carbon capture does is it takes all that CO2 that's in the air, whether it's from industry, whether it's from a volcano erupting, or anything actually, and carbon capture just pulls it in. So it's a bit like the opposite of a fan that blows air out, it sucks air in. So if we draw, they're very like this in Iceland, they're not like this everywhere, but if we draw a shape like this with a big kind of circular fan almost, with like rotating blades. There we go. So this spins, it pulls in the air, okay? It's called direct air capture. And that's the beauty of it. It's like a tree, okay? It's breathing in like a tree. And what it does is it takes that, and then what it can do is it can send it deep down in the ground. So it captures all this CO2 like this, and it can store it basically underground. And that gas, it's clever actually what they do. It sort of becomes like rock, so it solidifies, it calcifies actually is the proper term, and it'll attach itself to rock. So if we call that underground storage, and this is a really good thing. There is one negative, which it could leak, and it could actually cause, there could be spills of the gas. It could actually become a bit of a problem for water stores. But for the most part, underground storage is really good, and we want to write in there. So draw sort of these little rocks, and we want to put in brackets it calcifies as rock. So it turns from a gas into a rock, and that's really cool. Okay, so if we can kind of draw an arrow going from the industry. A lot of businesses are using this now to offset their emissions. Okay, so there's really good news for that. Now, the other thing they can do, and it wouldn't really go underground, but is they can transport it. Sorry, I'm not making a very good job of that. There we go. They can transport it, okay, into something that can be used. So basically the CO2, it's quite usable, and trucks will happily take it and transport it and use it for something else. And this process is called utilization. Okay, so that means it can become like a liquid fuel. So it can become something like petrol. It can be used for plastics. It can be even used for jet fuel. So planes and things like that. I'm not drawing a plane. I know you guys love it when I draw a plane, but it's honestly terrible. Oh, okay, I'll draw a plane, but it's really bad. Okay, let's have a go. So it'll just help you remember it. That's the idea. Oh, it's terrible. Right, that's sort of a plane. There we go. Little windows. Yeah, so there we go. Right, liquid fuels, plastics, and jet fuels. So that's amazing, right? They can take it out the air, they can use it again. So you can kind of see the pros in this situation. I guess we could let's just put a smiley face in there. Let's just go through them again. So we've got lower emissions, so less CO2 going out to space. We've got higher jobs. It's created a lot of jobs and quite well paid jobs as well. Even though some of this technology has been shared for free, the industry around it is really growing. Obviously there's so there's high economic benefits. You know, jet fuel isn't cheap. If there's a way of reusing things, recycling something to make it, that's going to huge cost savings. Also, let's not forget they can use existing oil and gas infrastructure for transport and storage. So that means they're not having to create new. Okay, so existing oil and gas infrastructure can be used. Okay, so the things like transporting it, storing it, that can be used. Now, there are some negatives. Just don't know where to put them. I'm going to go down here, I think. So, what are our negatives? Well, high cost. High cost. And that's true with any of these new technologies. There are also risks of leaks. Okay, so when it is piped down under the ground before it calcifies, which takes years and years, it could leak into drinking water, which is not good, and that's a risk to public health. Also, high energy use, which sounds odd because it's kind of offsetting the whole point of it, but the truth is, even though it's a bit offsetting emissions and those benefits from lack of emissions, it's still using a fair bit of energy, but not as much, obviously, as if it was not used at all. So it is still a good thing, but we must recognise that it does use energy too. So yeah, so there's your negatives, sorry, positives. There's your small amount of negatives. So if you do get a question that asks you about carbon capture, then you can sort of talk, if it's a 6 marker particularly, about the sort of pros and cons. So yeah, there you go.